Hello, and welcome to a video about volume of pyramids and cones. And in a couple of moments, we will also be doing the volume of a sphere. So the reason we put all of these together is they have one thing in common, and we'll talk about that at the end. So the volume of a pyramid and a cone are honestly the same exact formula. The volume of a cone and also a pyramid, you're about to find out, is 1/3 the area of the base times the height. Okay, now the reason it's 1/3 the area of the base times the height is instead of like a cylinder or a prism, which you've seen before, which have a flat bottom and a flat top, this tapers up to a point at the top. And that point at the top is called the vertex or sometimes called the apex. Okay, and there's not as much volume as there would be if it were a prism or a cylinder. So when you find the volume of a pyramid or a cone, it's 1/3 the area of the base times the height. I'm going to take a moment here to highlight that 1/3. 1/3 the area of the base times the height. So come on, little pen. So all you really need to know is find the area of the base. So if we're talking about a cone, the base of a cone is a circle, and the area of the base would be the area of the circle, which is pi r squared. And then the height is just the height. So instead of memorizing 1/3 base times height for a cone, it's a little bit easier to remember that the volume of a cone is 1/3 pi r squared h. So to find the volume of a cone, you need both the radius of the base and the height. Another important thing is, well, wait a second, Mrs. Bibber, which height are you talking about? Because there's the height technically right here, but then there's also this slant height, okay? What we're talking about when we say height is the altitude, which goes from the vertex down to the base, okay? I don't know why they have that extra stuff there for the axis. That doesn't mean anything. The slant height is the height from the vertex along the edge. That part's not useful to us for volume, okay? We do not need that for volume. 1/3 the area of the base times the height, and we're talking about the perpendicular height. All right, I've rambled enough. Let's move on. A pyramid has the exact same formula. It's 1/3 the area of the base times the height. So B is the area of the base. Okay. And in a pyramid, we have an apex, or sometimes called the vertex, and then we have the base. But the base could be a square. The base could be a hexagon. The base could be a triangle. Okay. So a pyramid is where you have a non-rounded base, okay, a polygonal base, and then it tapers up with triangles to the vertex on top. So the base is a polygon, and the lateral sides are all triangles that attach up from the base to the vertex. Okay, interesting little fun fact. If you were to unfold this, the net of a pyramid, this is called the net, would look like a square with 4 isosceles triangles coming off of it, and then those isosceles triangles bend up to the top to meet at the apex. Okay, enough about that. The volume. The volume is what we're here for. The volume is 1/3 the area of the base times the height. So whatever your base is, you just need an area formula for that thing, or you need them to have given you the area of the base. Okay? Let's try it out. So if we come to this first thing, I want a good color. Let's go with purple. Find the volume of the cone below in terms of pi and rounded to the nearest tenth. So we're actually going to give the area twice. We're going to give the answer in terms of pi, and then we're also going to round that same answer to the nearest tenth. We're going to do both things. We normally only ask you to do one, but I'm doing both in one example. So find the volume of the cone. All right, so the volume of a cone, we learned on the other page, is 1/3 pi r squared h. Well, look at that. That's handy. They gave me the radius. They gave me the height. Sweet. So our volume is 1/3 pi 21 squared times 42. So I am going to pull up my calculator, and while we wait for it, how's everybody doing? Everybody having a good day? I'm having a good day. I learned how to make a new recipe last night, and I had the leftovers for lunch, and they were awesome. Okay, so if I come here, I need to do, now if we're going to get this in terms of pi, I want to do the 1/3, ignore the pi, do 21 squared, and then do 42. and I have 6,174. So this volume is 6,174 pi, and this would be cubic millimeters. And there's my volume in terms of pi. If I then wanted to round that to the nearest tenth, I would just pull out my calculator and multiply that 6,174 by pi and get 19,396.2. 19,390, I forgot a number, 96.2 cubic millimeters. Okay, so now we want to use the volume to find other things. Now, if I'm talking about a cone, I'd really like to see a cone. So here's a cone, and the volume is 48 pi. And the height of the cone is 27. And they want the diameter of the base. So I'm probably going to want to find the radius first and then turn it into a diameter. That's kind of where I'm feeling. So let's see, the volume of the cone is supposed to be 1/3 pi r squared h. Well, the volume they gave us was 48 pi. I do not know the radius, but I do know that the height is 27. Now they want us to solve for the diameter of the base. So I'm going to find the radius and double it. All right, well, if I want to solve this, first thing I'm going to do is I'm going to divide both sides by 27 pi so that I can try to isolate this r here, because these pi's would divide, those 27s would go away. And so 48 pi divided by 27 pi, my pi's will go away. So 48, that says 58. 48 divided by 27 is, oh, that's a yucky looking decimal. So I am going to math frack it and get 16/9. Okay, so I have my face in the way is what I have. So I have 16/9 equals 1/3 r squared. Now I got to get rid of that 1/3. So I'm going to multiply both sides by 3. And so this will just be r squared. Well, 3 goes into 9 3 times, so this is now 16/3. And then if I want just the radius, I would take this and square root both sides. And my radius is the square root of 16/3, which is not a nice number. It's fine. Okay, I can live with it. So there's my radius, which means my diameter is 2 of those. Now, the question didn't tell me what to put it in terms of, but this is obviously a disgusting looking number. So I'm going to put that in my calculator and round to the nearest tenth because I feel like it. We would be more specific if we knew what we wanted from you. But in this case, I was not specific in the question. So I get to make the rules because I made the worksheet. All right, so 2 times the square root of 16/3 is 4.6. So our diameter was 4.6. Now, a lot of things went on there, okay? What we did is we used the volume formula to backtrack and find the radius. All right, example 3, find the volume of the square pyramid. Okay, let's see. I want a new color again. I'm going to go with orange. Find the volume of the square pyramid. Okay, so the volume of a pyramid is 1/3 the area of the base times the height. My base is a square. A square pyramid has a square on the bottom. A triangular pyramid has a triangle on the bottom, and so on. So that's 12 by 12, which means the area of the base is 144 because it's length times width. So my volume is 1/3 144 times 6. And then that I can do in my head because 1/3 of 6 is 2. 2 times 144 is 288. And so my volume is 288 cubic meters. Easy peasy. Find the volume of the square pyramid down here. Okay, so I need the area of the base times the height. Uh-oh. Well, they didn't give me the height this time. They gave me the 7.2. Not sure how that's helpful yet. But the volume is going to be 1/3 the area of the base times the height. So let's see, the area of the base. I can do that if it's a square. This is 8 by 8, which makes that whole base area 64. So I know I have 1/3 times 64, but the height, I don't have that yet. All right, now how am I going to find that height? I'm going to erase this 64 here and say, you know what? If I come down here, the height I want is right here. This 7.2 is my slant height. And if I draw a line over here, I can make a right triangle. So what I really have is my height is here. The 7.2 is the hypotenuse of the right triangle. And this distance down here is half the width of the square. So that's going to be 4. So to find my height, I need to do Pythagorean Theorem. So 4 squared plus h squared equals 7.2 squared. Now let's solve for h. So I have to do 7.2 squared and then take 4 squared away. Oh, my calculator is glitching here. 7.2 squared. Take away 4 squared. And that gives me 35.84. And if I square root that, what kind of number am I going to get? I don't know if it's going to be nice or not. It is not. 5.986. Let's round to the nearest tenth again. And if I round that to the nearest tenth, it's going to be 6.0. So my height is 6.0, which makes my volume 1/3 of 6 is 2. 2 times 64 is 128 cubic inches. Okay. So we're doing pretty good. I'm going to do spheres right now because they are not going to take a while, and then this video will be done. One video, a little bit longer than usual, but we got this. The volume of a sphere. Volume of a sphere is similar to the others because it has a third in it, except not really. It has a 4/3 in it. The volume of a sphere is 4/3 pi r cubed. That's it. All you need is one thing. You need the radius. Once you have it, you know the volume. So it says find the volume of the spheres below. Well, if I have this basketball looking thing and the diameter is 30 centimeters, I know my radius is 15. So the volume is 4/3 pi 15 cubed. And if I want to do that in terms of pi, I'm going to do 4/3 times 15 cubed and get 4,500. 4,500 pi cubic centimeters. Or if I want to round to the nearest tenth, if I do 4,500 times pi, I get 14,137.2. 14,137.2 cubic centimeters. And if I want to do a baseball, same thing. 4/3 pi r cubed. Don't make it hard for yourself. It's not. 4/3 pi r cubed. Let's just do this one to the nearest tenth because I'm feeling lazy and this video is getting long. 4/3 pi times 1.5 to the third. Bing bong. 14.137. So let's say that's 14.1 cubic inches. All right. Example 2 says find the radius if you know the volume. All right, last example here. So find the radius if you know the volume. So I have a sphere, and it has a radius that I don't know, and I know its volume is 288 pi. So volume is 4/3 pi r cubed. 288 pi equals 4/3 pi r cubed. I'm going to divide both sides by pi. And then say, okay, 288 equals 4/3 r cubed. I need to get rid of this 4/3. So technically what I'm going to do is divide both sides by 4/3, but that's the same as multiplying both sides by 3/4. So I need to take 288 and multiply by 3/4. I did it again. Keep hitting 3/5 instead of 3/4. There we go. 216. So 216 equals r cubed. Now I need to cube root it. So there's a square root. There's also a cube root, if you didn't know that. And in your calculator, to get to that cube root, you're going to go to math. And then number 4 is the cube root. And I want the cube root of 216. And the answer is 6. So the radius of the sphere is 6. Quick note, vocab term, if it says hemisphere, that means you're doing half of a sphere. So if you get questions, which you will, about hemispheres, you just have to know that that means half of a sphere. I'm done. Your video's done. Hooray! End of volume. I hope everybody's having a good day. Right now, as I record this, it is finally warm out. It's like 70-something degrees, which makes me very, very happy. And you're going to do your assignment in Delta Math. So make sure that you understand how to do this. Talk to you later.